title of the session is How Do Aeroplanes Fly? We'll go to the next slide. Just to give you an overview of what we are going to discuss in the next maybe 20-25 minutes or so. We are trying to find out, we will first discuss how or what it takes to be able to fly. We know that we cannot fly. So we'll just address what it takes to be able to fly, and we will see briefly how do aeroplanes manage to fly. Yeah. So what does it require to fly and how do aeroplanes manage to fly? We will just look at the fundamental aspects of it, how aeroplanes fly, and without resorting to the jargons or theories which are used in this field, and we will try to rely only on the physics that you are familiar with, the laws of physics that you have studied, and the concepts that you already know. So that's the attempt in this particular session. Before we address the issue of how do aeroplanes fly, let's pause for a while and think, why is that we are not able to fly? We know that even if we want to fly, we are not able to. In fact, we cannot be in the air for more than a few seconds possibly. If you jump up, you will be pulled down, and we know why it happens, because the force of gravity, the gravitational force always acts on us. So that's why we are not able to fly, but we know that we can walk. How do we walk? We exert a force on the ground by our foot, and there is an opposite force created because of friction, which will be in the direction that we are trying to move. So that force, that is the force which is created as a reaction because of friction, keeps us moving forward. So when we walk, there is a force that we apply on the ground, there is a reaction that is created by friction which keeps us moving forward. Now, we know that though we cannot fly, there are birds which can fly comfortably. Please just take a look at this particular peacock walking so majestically. The video is not mine, it's taken from YouTube. I've shown the link in the slide. See how so when it wants to fly, it's able to lift itself into the atmosphere. It's able to lift itself into the air by flapping the wings. So that's how birds fly. Now let's try to understand how aeroplanes do this. That is, when you consider an aeroplane, so the image that you see there is an aeroplane which is parked in the airport. So it's grounded, it's standing on the ground. Now, what we are trying to understand is what it takes for the aeroplanes from a state of being grounded or being parked in the airport to be airborne in the next, as it is in the next image. So that's what we are trying to address now. That is what it takes between these two stages. That is when it is grounded as opposed to when it is in the air. So on ground versus in air. As we know, when the aeroplane is standing in the airport, it's parked in the airport, the force of gravity is acting on the aeroplane the same way as it is acting on us. So as it is indicated by that red arrow, there is the force of gravity which keeps it down. Whereas when it is up in the air, the force of gravity, again, please look at the second image. The force of gravity continues to be acting as indicated by the red arrow, but there is another force which is shown by that green arrow in the picture. There is another force which is opposite to the direction, which acts opposite to in a direction that is opposite to the direction of the force of gravity, and it's a second force which makes the aeroplane which helps the aeroplane to be in the air. So what we are trying to understand is how is this upward force created? That is, there is a force which lifts the aeroplane up. how is this force created? How does the aeroplane manage to get this force which lifts itself up into the air? Now, before we try to understand the physics of it, let's look at how actually aeroplanes get into the air. So for that, we are just looking at this video again, this from YouTube. This video which shows us some takeoffs of aeroplanes. That is, as we know, there is a phase called takeoff. That is where the aeroplane run along the runway. The aeroplanes run along the runway before they take off into the atmosphere, before they take off into the air. So it's a long runway. After the initial run, the aeroplane gradually lifts itself up into the atmosphere. Let's look at another one. The same way, the runway is well paved and it's quite long enough for the aeroplane to come to a speed at which it can lift itself into the air. So after the initial phase of run, the aeroplane gradually rises up into the air. And typically, this is the way all the aeroplanes that we see in the airports take off. Then let's look at another one. This is seemingly a bigger aeroplane. So I would expect that this will take a longer distance to push it itself or to lift itself into the atmosphere. It picks up speed as it runs through the runway. Goes for a longer distance and gradually takes off into the air. So this is typically what the aeroplanes do. They run for some distance before they move into the atmosphere. Now let's see what happens. What happens when the aeroplanes run? Before that, please pause for a while and think of what happens when you run. When we run on the ground, when we run, even if there is no wind blowing otherwise, when we run, we feel that air is flowing past us. When we run, we feel that wind is blowing past us. That is, wind is blowing in a direction that is opposite to the direction of our running, right? So this is a usual experience. The same thing happens when the aeroplane runs on the runway as well. When the aeroplane runs, wind flows past the aeroplane. So if you consider the aeroplanes to be stationary, it's actually what the aeroplane would feel is that the wind is flowing past its body. What happens when such a flow of wind or such a flow of air takes place over the body of the aircraft? Let's try to understand that. We are just looking at the component that is called wing. I just encircled the portion of interest. That is, if you were to cut across that particular section, you will see something like, see that shape again in the second image. It's encircled with a red round. So please look at the encircled portions there. It shows the section of the wing. It has a picking of air along that section. I repeat, when the aircraft is moving, it experiences flow of air along or across that particular section which is highlighted in that picture, in the two pictures. So this flow happens all over the aeroplane. Particularly, we are focusing on the flow that is taking place over the wing of the aeroplane, because it's a wing which helps the aeroplane lift itself into the atmosphere. Now just look at that particular cross section. We'll try to focus on it with another picture. Just look at the same section. I just zoomed that in to a different picture here. The attempt in this picture is to depict the flow of air by those bluish and white lines. So you can consider it as fluid particle, that is particles of air, the flow of air that is taking place across the section of the wing. So I've shown that yellow arrow to indicate that we are cutting across that section and looking at what happens when the aircraft is running. So when the aircraft is running, there is flow of air across the section of the wing. I just repeat the same sentence. When the aircraft is running, there is a flow of air across the section of the wing that we are seeing in the picture. Now, what happens when air flows across that kind of a solid surface? The peculiar geometry that you have in that picture, it ensures that when the air is flowing over it, the air is somewhat deflected downward. That is, it's because of the geometry that is provided for that particular section. So the wings are created with this kind of section in such a way that when there is a flow of air across that section, the air gets deflected downward. The deflection downward, you can actually notice that in the picture, we can see that all the lines that you see there, they are sort of turning down towards the trailing edge of that particular section. This is what we mean by the flow getting deflected downward. Now, so what? What happens if the flow is getting deflected downward? This, what we are calling this deflection, is actually a turning of the flow. Now, few things happen because of turning of this flow. What really happens is the wing, because of its peculiar geometry, is exerting a kind of pressure in such a way that the flow is getting deflected. So, in effect, this is like a downward force that is being exerted by the wing. So, when the wing is exerting a downward force on the air, there will be an equal and opposite force, as we know by the third law of Newton. There will be an equal and opposite force acting on the wing, acting on the bottom surface of the wing, which will be vertically upward. So, this is one consequence of turning of the flow. In fact, the turning of the flow, though it looks quite simple in the picture, it entails some of the complex aspects of fluid flow. But then the result of these complex phenomena is there is an upward force, and the pressure distribution. If you consider the pressure, you are familiar with atmospheric pressure, fluid pressure, etc. So, if you consider the pressure that is exerted by air all around the wing, the distribution of pressure is in such a way that the pressure on the bottom side, I repeat, the pressure exerted by the wind, the pressure exerted by air on the bottom surface of the wing is higher than the pressure that is exerted on the top surface. Why this? This is because of the entire flow configuration, that is the deflection that we just mentioned about. So, because of the deflection, the pressure distribution is in such a way that there is an upward force which is higher than the downward force that is acting on along the surface of the wing. So now let's consolidate what we just discussed. There is an action and reaction. There is a pressure disturbance. There is a pressure distribution in such a way that there is a resulting upward force which is higher than the force that is acting downward, which means that there is a net force which is acting on the wing. There is a net force acting on the wing in the upward direction. So the whole thing happens because of deflection of the flow. So there is a flow is getting deflected because of the geometry of the wing. Because of the deflection, there is a net upward force which is created, which is acting all over the wing. So that's upward force that we have been discussing about. Now, so what happens is, just repeated with a different picture here. Again, zooming in on to the shape that we are talking about, that is the section of that particular wing. So there is a net resultant force acting on the wing, and this force, when that force is large enough to beat gravitational force, the aeroplane will lift itself into the air. Just think of it. There is gravity, there is downward force because of the weight. because of the gravitational pull, there is a downward force acting on the aeroplane, which is because of its weight. Now, when it runs, there is a flow of air across the section, and the section of the wing is in such a way that the flow is deflected downward, and the deflection causes an upward force. So now you have two forces, the gravitational force which is acting downward, the upward force which is created by this flow deflection. Now, when the upward force is higher than the gravitational force, that is the force which is lifting up, when that is higher than the gravitational force, naturally the aeroplane will be lifted up into the atmosphere. So this is what exactly happens when the aeroplane is running on the runway and eventually taking off. So let's now, with this concept in mind, let's once again look at the takeoff. The same video, actually we'll just see one takeoff. So the aeroplane is running along the highway, air is flowing past its wing, the deflection is happening, though we cannot see it. The deflection is happening, because of that there is an upward force. As the velocity increases, the upward force also increases, the upward force keeps increasing, and when it is equal to gravity and when it exceeds gravity, the upward force wins the race and it pushes the aeroplane up. So when the aeroplane is up in the air, gravity is still acting on it. Gravity is still acting on it, but now the upward force is higher than gravity when the aeroplane is that is when it is taking off into the air. Actually, when it is flying level, it's actually equal. They both are equal because they are in gravity is acting downward, the upward force is acting up. So now that's how the aeroplane gets into the atmosphere. That is when the force which lifts it up, the lifting force is higher than gravity, then the aeroplane gets into the atmosphere. Okay. Now let's pause for a second. So what we are saying is that when the aeroplane runs across the runway, there is a force which is created which lifts it up into the atmosphere. But then there is so that is the upward force that we are talking about. So keep in mind that unless the aeroplane is running, there is no upward force. So the aeroplane, for the aeroplanes to be up in the air, it needs to be moving forward, or the aeroplane cannot stand still in the atmosphere. If it stands still, it doesn't get the lifting force. So it has to be keeping on moving. So that's basically, that is, if there is no velocity, there is no upward force. So please keep that in mind. Unless the aeroplane is moving, it cannot keep itself up in the air. So because gravity is always acting on it. So if it has to defy gravity, it has to be moving forward, which will help it create the lifting force. Okay, now let's move forward. So then the next question is, how does the aeroplane move forward? So I just mentioned about the fight between the lifting force and the gravity. That is acting vertically up. The lifting force is vertically up, gravity is acting vertically down. Now the question is, how does the aeroplane move forward, that is in the horizontal direction? So to begin with, that is when it is running on the runway, how is it able to move forward? Because the forward movement is required to create the gravitation, to create the force which is lifting, and obviously for it to be flying at a high velocity, it needs to have some force which is acting in the direction of motion. Look at that red arrow which is indicating that. So if it this is showing a horizontal flight. So if the plane is going horizontally forward, there should be some force which is acting on it, which is pushing it in the horizontal direction. The force that we talked so far is a force which is acting vertically up. So we need to have another force which should be moving which should be pushing it forward in the horizontal direction. How does the aeroplane create that force? This force is created by another component called the engine of the aeroplane. The engine. So far we spoke about the wing. Now we are focusing on the engine, that part which is highlighted in that particular picture. That is called the engine. Actually, it's much smaller than the wing. Wing is a quite lengthy, huge component. As opposed to that, the engine of the aircraft is typically very small in relation to the size of the wing actually. Okay, now what does the engine do? The engine, first thing, it takes air from the atmosphere. It takes in air from the atmosphere and it burns fuel. Now, burning of fuel in air is nothing new. When you see a bike, when you see a car running, when you see a bus, when you see a train, all of them have fuel, right? We know that they all of them use petrol, diesel, etc. Right? So all of them make use of fuel. What do they do with the fuel? They burn the fuel in the engine. The energy in the fuel, which is in the chemical, which is, as you know, is the chemical energy, due to the burning process, the chemical energy gets converted to thermal energy. The same way, aeroplane also burn the fuel and converts the chemical energy to thermal energy within the engine. So that happens within the within this component that we are talking about as the engine. Now, after the energy is released to or converted to thermal energy, the engine or the other parts, remaining parts in the engine, converts that thermal energy into another form of energy which you are also familiar with, the kinetic energy. Kinetic energy, as you know, is related to velocity, right? So the engine components are designed in such a way that this thermal energy can be converted eventually to kinetic energy, which means that air comes in with some velocity and the velocity is accelerated. That is, when you say that energy is converted, fuel energy is converted to kinetic energy, it means that there is energy added to the fuel. So which means that air is coming with some velocity, leaving the engine with a higher velocity. I repeat that, air is coming into the engine with some velocity, and because of the processes within the engine, air leaves the engine with a higher velocity. So that additional energy for that kinetic energy is coming from the fuel. Okay, so what happens when it leaves with a higher velocity? Higher velocity we know is associated with higher momentum, mass into velocity. Mass is almost constant here. So we will assume mass to be constant. So mass is constant. So when velocity is high, you have a higher momentum. So air is coming and going out with a higher momentum. So there is a change of momentum. Now recall Newton's second law. There is a change of momentum. So there is a force which is equal to the rate of change of momentum, right? So the aeroplane, the engine is exerting a force on the stream of air that is going through it. As a result of it, again, the third law acts, the third law applies here. There is an equal and opposite force acting on the engine. There is an equal and opposite force which is acting in the direction of flight. This force gets transmitted to the engine and that keeps it moving forward. So to summarize it, air comes in, fuel adds energy to it, air goes out with a higher velocity. Because of the transfer of momentum, because of the increase in momentum, there will be a force, there will be a reactive force which is in the direction of flight. So as a result of all this, you are now creating a force which is in the direction of motion and that keeps the aeroplane moving forward. So now we have discussed both the aspects, both the aspects, how the aeroplane gets into the air and how does it move forward. Just to summarize the whole thing, the force that is required to stay in the air is created by the flow, actually the deflection of air by the wings, and this is caused by the runway, that is caused by the running of the aeroplane along the runway. Now as a result as a result of this lifting force, the aeroplane is able to keep itself up in the air. Now the force required to move forward even during the runway, the force is created by conversion of chemical energy to chemical energy in the fuel, eventually to kinetic energy, and and due to the exchange of momentum, there is a force which is created, and the force is created in a direction that is opposite. The force is applied in a direction that is along the direction of flight. So this force keeps it moving forward. So This is, in summary, the forces, the two forces that keeps the aeroplane up in the air and moving forward. So we have just looked at the how these forces are created from a very fundamental perspective, very fundamental frame of theory that is which is all familiar to you, the concepts, the physical laws which you have all studied, and this entire field that deals with the design, development, manufacturing, control, etc., or a lot of activities that are related to aeroplanes is referred to as the field of aerospace engineering or aeronautical engineering, a very exciting field in which a lot of uh, path-breaking research is going on worldwide, and many of that is going on in India as well. So with that, I wind up.